The next thing that I want to talk about are mutually exclusive events. Now, these events have nothing in common whatsoever. They can't occur simultaneously. Let's look at the Venn diagrams. You see here that we have two events in the sample space, and there's no intersection between them. Right? So let's just take a look at an example here. Right? When rolling a die, let's define event A as getting at least a 5. So that means that A, right, will have the results 5 and 6, and B will be defined as getting a result of 3. So B, right, the set of results here would be just one number, 3. Now what's common between A and B? Well, there's nothing in common, right? So that means that A intersect B, well, that's an empty set. Now we can also write an empty set as the Greek letter phi. Now, as we said, A intersect B, that's an empty set. So the probability of A intersect B, well, that equals to 0. Now, what about the probability of the union? Well, we know that the probability of A union B, well, that equals to the probability of A plus the probability of B minus the probability of A intersect B. Well, we know now that there's no intersect between A and B, so the probability will be equal to 0. So that means that that equals to the probability of A plus the probability of B only. That's the probability of the union. This is exactly what's written right here. Okay, what about the next term? The next term are subset events. Now, let's take a look at the Venn diagram. If we have an event A, then B is totally encased in event A. That means that all the results of B, we can see them in A as well. Okay, so if B is a subset of A, then event A contains event B. That means that all the results in event B are also contained in event A. Now, this connection is denoted like this. If B is contained in A, this isn't a C, this is the symbol, the mathematical symbol for contained. Then we have this, A intersect B, well, that equals to B, right? What's common between A and B? Well, B is common to both events. So A intersect B would be B. So the probability of A intersect B would be the probability of B itself. Now, what about A union B? Well, if we take, right, all the results in A and all the results of B and we put them in the same list, then we'll get the results of A. So that means that A union B, well, that equals to A. So the probability of A union B, well, that would be equal to the probability of A. Now let's take a look at an example, right? If we, again, we're rolling a die, and